Okay, so today we're looking at even odd functions and a little bit about transformations. And we talked about what makes a function even or odd, and it has to do with the symmetry. And let's go back and discuss that one last time. So a function is even, like when we were talking about sine and cosine, when it is split across the y-axis. So the test for that is to put a negative in and see if it gives you back the same function if you put negative x in where all the x's are. So this is like it has y-axis symmetry. And odd functions, if you put a negative in with the x and then you put a negative times the whole function, that should show it has origin symmetry if they come out the same. So in our first example, I have g of x equals negative 3x squared minus 5. And what you do is you do both of these tests. So first you put the word even, and then you describe the test you're doing, and make sure you change the function name to the name of what function you're working with, like g of x, because I just about wrote f of x down for this problem. And I'm going to put a negative g of x. So on the left side of this problem, we have the original problem. What we're going to do is put in negative x and compare what happens. So negative 3 times negative x quantity squared minus 5. Now, we know that when you square a negative, it goes away. So that gives me negative 3x squared minus 5, which matches the other side. So I say they're equal. So yes, this has y-axis symmetry. So yes, it's even. Now you have to do both tests to prove that it's not odd. Now, not that a function can be both, but it's just to prove that you have done the math correctly on the other one and that the odd test will not work. So first, you'll notice that part of the odd test is to do the same thing that the even test did, put in negative for x. So you can just recopy that part over here, and yes, you do have to recopy it because this is a separate part to the proof. And then over here, you're going to put a negative times the whole entire question. And negative times a negative is a positive 3x squared, and negative times negative is a positive 5. And these are not equal, so you write a not equal symbol between them when they don't work, and say no. So now we know this problem is even. Let's do one more example of this, and this time let's work with a fraction because I think that would be important. So we have h of x, and it's a lovely fractional problem, as you can see. And I've already written up the two tests that I need to do for h of x. And we're going to start off by looking at what if we compare the original fraction, which has a negative on top, on monomial with a binomial on the bottom, to putting in negative for the x in both places. So first of all, we know a lot more about squaring them, so let's look at the bottom. When you square out that negative x times negative x, it becomes positive x squared. Now with a cube, it's a little different because first you got to work the power. Even though there's a negative on the outside, I've got to work the power first. So negative x times negative x times negative x is negative x cubed, and that brings the cube on the inside and keeps the negative. But then two negatives make a positive. So you need to be careful because that one on the outside doesn't get used until the one on the inside has been done. So now I see they're not equal because one's positive and one's negative on the top. So maybe it's got a chance of being odd. So first we recopy the work that we have, showing the math for what happened to the negatives if you put negative inside for the x. So again, you're just recopying the work you had earlier. You just got to make sure you recopy it correctly. Now over here, we're going to do negative times the whole problem So that's like negative 1 over 1. Let me write that better. Times the whole problem. And we really get an opportunity to see where do we want to put this negative. Because as we talked about back when we were doing symmetry, you can do it to the numerator or the denominator. So I looked down here at the bottom of the first column and I realized that the top is an opposite sign than the problem originally, but the bottom still matches. So I think that would be really important to multiply that negative 1 to the top. If the bottom had the wrong signs, then I'd be multiplying it to the bottom. And that comes out x cubed over 3x squared minus 9. And I'm just going to draw an arrow down instead of having to put that next to the second one. So they're equal. So this one is yes. And this one was no. So that's what you're doing with symmetry in terms of proving something's even or odd. So with even and odd functions, you could graph them to kind of see what kind of symmetry they have, so you'll know what kind of math you're expecting to happen in your proof, and then that way when it comes out to show what you think it's going to have, then you would have a better option of knowing for sure that you have it correct. So now let's look at some transformations. So it says describe the transformation of f of x to the parent function. And I've gotten two square root graphs here. And in these square root graphs, we're looking for the fact that they are supposed to be compared to the square root of x where there's no numbers on the function. So for example, the square root of x graph, if you put in 0, the square root is 0. If you put in 1, the square root is 1. The next number that has a square root is 4, because the square root of 4 is 2, and it looks like a curve like this. Now, these obviously don't look exactly the same as that. And let's see, how are they changed? Well, first of all, one of the transformation changes that can be made to a function is the fact that we can move it around, we can stretch or compress it, or we can reflect it. Now, these two problems would be the children of this parent function f of x equals the square root of x. So question number 1 is going to be the child g of x. Now, he's going to look somewhat like his parent, but he's not going to be the same. And this other problem is going to be h of x, the second child. So we're going to see how do these children look similar to their parents. Well, first of all, the first one is reflected. So that means there would be a negative in front of the square root. Where the second one is not reflected, so there would be no negative in front of the square root. Now this first graph is moved to the right 3 and up 2. And so therefore it would be some kind of translation was sliding. So we would need to show that. The second one is to the left 2 and up 3. So we'll have to figure out how do you show that. So left-right motion, when we were doing our sine and cosine, if you remember, sine would be something like x minus pi over 2 plus 3. And we would set that parentheses equal to 0, and that would tell us it went to the right pi over 2, because the opposite of subtracting is adding. So if I want to put this back in here, then I've got to make it look the opposite. So the opposite of right 3 would be minus 3. And the opposite of the left 2 would be x plus 2. Now the number on the end when we were studying sine was our up and down number, and it did exactly what it was supposed to do. So for up 2 you would put a plus 2. If I was going down, I'd have put a minus 2. And so on this one I put plus 3. So in your homework, it's going to be matching. You're going to match the graph that's already been drawn to an equation, but you're going to describe how it's related to the parent function. And the parent functions on those are x squared and the absolute value of x. So you want to look and see what you can see there. And they may also have some stretch and compress to it. This particular graph, I can't tell a lot about stretch or compress because I don't have enough of a graph with two sides to see that. But with the ones that you're going to be looking at, you're going to be able to see it with stretched or compressed because it's going to be obviously wider or narrower for that stretch and compress. So now you can go to Canvas and work on your homework for 1.4.